Welcome to Neal on Fire, the podcast where we talk with innovators who are shaping the future of wildfire and climate technology. Today, I'm joined by Paul Schwartz, the co-founder and CEO of Senarch, a company helping to power forest and wildfire IoT monitoring under any conditions in any location. Paul, thanks for joining the podcast today.
Thank you for having me. It's a pleasure.
For those who don't know Senarch, what do you do and what problem are you solving?
We are providing a communication device that enables a wireless IoT network in the off-grid environment to be deployed anywhere and creating this kind of connectivity in areas that traditionally were not feasible. So beyond the reach of grid power, outside the coverage area of cellular and so forth. So we're basically creating a bubble of connectivity where there is no existing infrastructure.
So presumably you're using solar, and we're going to add some images in here as well for folks to see. But beyond that, solar is part of the equation, the other part being the battery power. And sometimes you get a little bit of life out of a battery, sometimes you get a lot. So with solar, given that you've talked about it being an off-grid solution, how long can you kind of stay in the dark, if you will?
Exactly. Our solution is driven and powered by the energy from our sun, and we harness and harvest the energy from the sun on a battery, and the battery is then able to power the electronics. And we can with the largest battery, we have 3 different choices of battery depending on where you are on the planet. We can configure the solar panel and the battery dimensioning to fit the area. But the largest configuration will provide you 30 days of operation on battery alone.
Wow, that's impressive. So given that I believe that you're primarily LoRaWAN connectivity, is that correct?
We also do IoT, which is a new German protocol, which is growing in adoption in Europe. But the primary product for us at the moment is the LoRaWAN gateway.
So what inspired you to start this company and put this device together?
Good question. So a couple of years ago, I met this young chap who is now my business partner. He had graduated from the technical university here in Copenhagen with the prototype of what we're now further developing and commercializing. And he had gotten the idea to do this off-grid solar-powered gateway from a project here at the university where he saw that the university had purchased 4 LoRaWAN gateways to be deployed outdoors on top of the buildings. And he also saw that the budget for this investment had overrun by 400% simply because of the the manpower and you could say the labor costs of pulling the wires and pulling the cables to the roof and powering these 4 gateways with normal grid power. And he got to thinking that this has got to be easier and better and smarter. So he sat down and he wrote this intelligent software that is able to optimize energy consumption in the electronics. He also chose the right components and put together this kind of, prototype that even today is still running on the roof of our building. And this is on the 3rd year now of that. And he was then accepted into an incubator program here at the university. And through that, I got to know him. He was looking for a co-founder, and we put together the team that we have today, and we raised the capital, and we're now in 2nd year of operation.
You mentioned Copenhagen. So are you primarily based in Europe, or what are the other areas? Are you in the US or in North America?
We are based in here at there's this, what we call the DTU Science Park, which is kind of like an office that is on the campus, but it's for small companies, startups and scale-ups. And we live here. We're based here, but we have customers in the US as well. We have units deployed across, one in California, one in Cleveland, one in New Hampshire. But we're still working on this kind of growth of the clients that we're working with there.
LoRaWAN has such a big ecosystem of devices, just covering so many different applications. Where do you find the typical uses for your gateways? What are you normally connecting together?
Yeah, so our key segments and where we see the most traction is within the utility space, providing this kind of off-grid connectivity solution for monitoring assets and infrastructure in the off-grid environment. This is also being done by commercial LoRaWAN operators, network service providers. So servicing the energy and utility space, we're basically either going direct or we're going indirect by also offering and providing our solution to the commercial operators such as Senet, which is now Netmore in the US, Netmore in Europe, CPCom here in Denmark, and we have a few operators across the European continent, but mostly dominated by the larger multinational companies.
So we covered the power consumption and solar and so forth. What about communication? So is that primarily cell, satellite, a combination of both? How does that work?
Yeah, so we have this kind of least cost routing mechanism that if there's a Wi-Fi connection, we can use that. If there is cellular, we'll use that. We have a built-in LTE modem, so you plug in a SIM card and you're off to the races. But if you're outside of the cellular coverage area, we can also work with a satellite modem. So we have an optional satellite modem, and we've also developed something that we call gateway relay, which is for those applications where you really want to reach into the really remote sites and those kind of, like, for instance, when we're talking about wildfire, typically, you're going to have sensors and our gateways in nature. And for those areas where the cellular doesn't reach, we can do what we call gateway relay, where we basically bounce the sensor data back from one gateway to another. So you imagine a string of pearls making up our gateways, and we can have from everything from 1 to up to 8 gateways in a string of pearls, and we can then relay that sensor data back to an area where there's internet connection. In other words, where there's a cellular connection.
So you pretty much can be anywhere regardless of what's available in terms of communication.
Exactly. And because LoRaWAN is so long reach, it's such long range, where you're talking miles depending on the line of sight and the local topology and whatnot. But if the conditions are there, we can cover huge distances that way and really go into very remote applications and locations. Sorry.
You talked about utilities as being a key market for you. What about for the viewers of this, primarily concerned about climate, forestry, wildfires? What are some of the either existing customer use cases that you have, or where do you see this being a home run for deploying those kinds of monitoring solutions?
Yes, being that we're in Denmark is extremely flat and we're very close to the sea level. We are, of course, providing our solution in those areas where you want to monitor for flooding, flash floods from the sea. So, sensors measuring the sea level and also the water level in streams and rivers, because this can be, a flash flood can happen, very quickly with a storm, or if the wind is in the wrong direction, so to speak, you'll have, damage from water. And what we're doing here is that we're enabling these kind of sensors in locations that are really, really difficult to cover from the cellular network, for instance. So the benefit is the coverage, but the benefit is also that the LoRaWAN sensors are extremely energy efficient. So one water level sensor can on the battery it has can live for between 5 and 7, sometimes longer, 7 years, 5 to 7 years, which means that LoRaWAN is an ideal solution for these kind of remote sensoring devices.
Are there a couple of use cases you could share that might illustrate how this operates in a remote area, or perhaps in an unusual setting, different kinds of sensors?
Sure. When we talk about a wildfire, for instance, the idea here is to provide and deploy the gateways in such a way that they are, of course, in a location where they can harvest sufficient amount of energy from the sun, but still reach these sensors that are in situation in the nature, capturing this data that is then fed back and provide the actionable insights for the user. That could be air temperature, ambient temperature. It could be relative humidity. It could be soil moisture. Could be the moisture in the trees. And all this kind of data is super valuable if we're able to capture it in those high risk areas that normally are prone to wildfires. So the idea here is to actually using AI and data modeling to capture this data, marry that data with weather reports and historical data, and then crunch the numbers in AI, and thereby predict where are the high risk areas that we need to be aware of and focus our attention on before the ignition actually happens.
Sure.
And that could be control burns. It could be taking the fuels off, collecting fuel from the ground, things like that.
And Senarch's role in that is being the connector of all these sensors together. You're not necessarily providing a lot of the data that you talked about and the AI and so forth, but rather you're collecting all the sensor data and providing in a way that can then be integrated into some kind of an analytical platform. Okay.
Correct. We're in that sense, we're agnostic to the sensor type and the brand and the vendor, as well as the software analytics. We're just you could say the transport mechanism for the sensor data.
You're the plumbing.
Yeah, exactly. But
So
the point is also that LoRaWAN is a two-way communication protocol, which also allows the user to reconfigure sensors in the wild via the gateway that we provide. Update firmware, do new configurations. Maybe you want to change the frequency of the data that you're collecting. Maybe you want to update the sensitivity, those type of things.
So you're doing firmware updates over the air then for your device.
Correct.
Okay.
Correct.
So we talked about the battery and how you have 3 different levels of that. We talked about your battery management being part of the secret sauce that allows it to exist off grid for a long time. Other than solar panel and some other components here, is there anything else that you would consider to be part of the secret sauce that your company has engineered and kind of customized in this platform?
Yeah. Two main things that we normally say that we are the areas that are key innovations. One is the energy optimization. So we've reduced the energy load on the system, on the gateway system as a whole. So conventional gateways for outdoor use that are connected to grid power or PoE typically use from 9 watts of power and upwards, depending on the brand and make and model. We use in comparison between 1.1 and 1.2 watts. And this kind of ultra low power consumption enables us to have the system running for between these 25 and 30 days on battery alone, depending on the ambient temperature. So the lower the temperature, the lower, the fewer the days of operation, but we're in between 25 and 30 days. The second innovation that we've made is that we've embedded a LoRaWAN sensor in each gateway. And the function of this sensor is to collect the energy production and energy storage data, the temperature inside the enclosure, the relative humidity inside the enclosure. There's an accelerator, there's a tilt sensor that measures if the box has been knocked over in the wind. There's even a motion sensor that registers if the enclosure has been opened. So all this kind of telemetry data or health data from the system is collected in this sensor and transmitted over the LoRaWAN network back to the user. And so that means that even if the backhaul cellular connection goes or the satellite connection goes, or for some reason the system is defunct or has trouble, the user still gets this type of data back because the little sensor has its own little battery. It's self-powered, and it's basically sending data to itself in normal operation, but in a situation where the gateway is suffering, that data will be relayed from a secondary from another gateway in the coverage area. So the idea is to have more than one gateway, because that means resilience and redundancy on the network side, but it also means that this kind of sensor data from each gateway can be passed on to the next gateway if the gateway is malfunctioning for some reason.
So those who may not understand LoRaWAN and are listening or watching this, can you just take a moment and provide kind of a basic understanding of what that is?
Yes. LoRaWAN is a standards-based um, radio protocol. It's a communication protocol that has a radio modulation technique called LoRa, which stands for long range, and it's low power. It's extremely good at traveling far. It has long range, and it has the ability to penetrate. And because it's below gigahertz, in the US it's 915 megahertz. In Europe it's 868 megahertz, and it's really good at um, you know um, penetrating and traversing different types, buildings, different types of, you could say, interferences on the path. So trees, buildings, windows, plants. So you basically have a very robust radio. And then LoRaWAN then has a wide area network component. That's why it's called LoRaWAN, which means that you also have these kind of collision detection and quality of, not necessarily quality of service, but you have these kind of parameters that make it provide the ability to, for instance, do acknowledgments that you have actually received the data packets from the sensor. You can do confirm with the sensor that yes, we've received the data package. And this is key for us, because we're talking about an autonomous system, and using LoRaWAN in this realm where the equipment has to live its own life independently from everything else and do that for years. It's really important to have a very robust and reliable and standards-based communication protocol, which is optimized obviously for IoT devices, and it has a huge ecosystem also. So there's I would say you'll be hard pressed to not be able to find a type of sensor that will provide the type of data that you're looking for. And the co-host sensor that we've designed and put into our solution, the purpose there is to provide the user and the owner of the gateway with this kind of status and health data, which means that if there's something wrong, you'll know it before everything breaks down, and you can then do, you could say, preventive maintenance before the gateway completely goes down. But yeah, so we're using LoRaWAN because it's by far the largest ecosystem when it comes to IoT.
Great. So I'm curious, because it's never a straight path for any of these tech devices. There's always lots of, issues and speed bumps and things that come up along the way. So from that moment that your co-founder had that light bulb moment to now, what are some of the biggest tech challenges that you've had to overcome?
I think the biggest tech challenge that we've overcome is the ability to actually develop and manufacture and deliver products that are shippable and approved and certified in such a short time period. When it comes to the technology, I would say that one of the things that we encounter in some areas of the world is the ability to have a SIM card from the local operator that actually provides the right connectivity or has the right profile. This can be a challenge. I mean, internally, I think one of the challenges that we've been facing is probably a common challenge for all startups is the ability to actually gain traction and deliver and grow the company and find the right product market fit and deliver solutions and value to customers. And on the external side, I would say probably being able to find a one size fits all a solution for the SIM card and for the cellular network, which we need for the backhaul typically.
Sure. So you had pointed out some of the fundamental challenges with any kind of a startup in a tech space, particularly a very focused area like this. Who would you say is your ideal customer today, knowing that there's probably lots of different applications that you can address, but you don't necessarily have the resources to go after all of them? What are the markets that you're primarily focused on? And then how do you see that evolving in the future as you get traction in some of these areas where you're trying to move forward?
Yes. So I mentioned utility and energy companies. Those are definitely our key segments for us. But again, when you dig into the utility companies, it could be very nuanced, and there are many levels and many different applications. And one of the key applications in the utility space is remote metering, water meters, for instance. And we're being pulled into lots of those type of projects where either the utility company itself or a third-party commercial operator, telco, is providing the connectivity for these water meters. So there's a huge push for this in North America, in Europe, even in India also, and in the Far East. But we're seeing that those projects are mainly led for us, and our customers are mainly the telecommunications service providers, the operators. They order and use our solution as a very rapid and easy deployment model, because they don't have to worry about pulling cables to the roof. Just they rent space on a rooftop, typically a flat roof. They put up a pole, or they use one of our we've designed and also manufacture a tripod. So they use our solution. They don't have to worry about the electricity and the cabling and sub-meters and all that. And something that typically takes days and weeks can take, an hour or two max. So it's a very efficient, it's a very cost-effective rollout solution. So telcos, utilities, energy companies, but we also work a lot with municipalities and environmental agencies. We're working with the Cleveland Water Alliance in Ohio. They're taking care of the Great Lakes, making sure that the environment is protected. We find that project and those projects that we are involved in to be super interesting. I was just there a few weeks ago and met with the folks who use our equipment. It's just a joy to see how data can be used to protect our planet and our environment. So things like that, and we're also hoping that that this will become more prevalent in other areas of the world.
Yeah, thinking through the applications, I can see where you could have sensors for flooding, particularly since a lot of that happens in areas where there may not be good communications infrastructure or the ability to connect to shore power. And beyond that, other disasters, earthquakes, hurricanes, whatever it may be, because your device is going to be there no matter what. It has its own power. It has its own communication. So even if the cell network gets knocked off the air, it's still going to be communicating. So that it seems like there's a lot of climate and environmental use cases that should provide for an exciting future for Senarch.
Exactly. I mean, we're being introduced to these kind of projects where the headline is climate resilience. It's no longer, I mean, we're kind of beyond the point of no return in many respects, unfortunately, where it's not a question of reducing CO2. Of course, we still have to continue to do that and find new energy sources and reduce our carbon emissions. But the damage, has already been done. And so now we have to live with the new, the situations and the new conditions and the new weather phenomena. So those storms and really climate disasters that typically was once every 100 years, now we have to expect them maybe every third year or something like this, right? And so climate resilience is unfortunately, something that we're being pulled into because data is so crucial to being able to cope with these climate
so many different applications. I wonder what's been the hardest part about scaling Senarch so far.
It's the classic, the classic challenge of being a small company, being a newcomer to the industry. It's not because we don't have competition. So we have to stake our claim. We have to build the brand. We have to convince the customers that we're reliable and we're, trustworthy company that can deliver the value that we claim. The other side of that is also that we're introducing a new kind of product or a new kind of solution to a well-known problem. So being able to deliver a LoRaWAN gateway is nothing new. That's a standard, pretty much a commodity product. But being able to provide an off-grid solar power gateway that is very robust and very reliable is definitely something that is more challenging, and our users have to get used to that idea, because the competing products they're looking at, they have the ability to maybe sustain the system for 7 to 10 days on battery. We can sustain it up to 30 days, which is a completely different ball game, and of course that also comes at a cost. So being able to compete on price, at the same time also convince of the value, that's a challenge.
So what's next for Senarch? Do you have new devices, changes? What is the next year or so look like for you?
I think what we are focusing on right now is bringing the product that we have to market. We have some interesting things in the roadmap. We're going to be focusing, the last part of 2025. The year is pretty much over when it comes to purchasing and orders. We have basically 4 weeks left before people start going on holidays. Um, but 2026 will focus a lot of our attention on bringing the product that we have to market. Of course, supporting and improving it, taking care of customers, making sure that our customers are experiencing, having a good experience and having the customer success that we want them to have. But then we also have some optimizations that we want to do, small incremental steps. But you could say the big innovations and the new kind of revisions of the product are probably going to be in the latter part of 2026. And one of the things there is providing a more compact unit, where today we have the electronics and the battery enclosures as two separate enclosures. Going forward with the what we call the compact, that's going to be a combined enclosure with the electronics and the battery in one system, or in one enclosure.
Exciting things to come. Listen, thanks so much for joining me today and sharing the story behind Senarch. It's really exciting to see new approaches emerging in forest and wildfire and climate technology like what you're doing. Now, of course, we talked about you're the plumbing, but without that, all of this would not be possible. You can have the best sensor in the world, but if it doesn't have a way to get the data through cell or satellite and through the cloud and down to a dashboard somewhere, it's not going to be of any use at all. So it's really exciting to hear about that and how you're connecting all these solutions together and really kind of being an important role in the climate and wildfire and forestry world. So for listeners who want to learn more, you can check out Senarch online and follow their progress, learn more about the technology. And if you enjoyed this episode, please be sure to subscribe to Neal on Fire for more conversations with innovators like Paul, who are making a real impact in wildfire and climate tech. Thanks for joining.
Thanks for having me. Thanks, Neal.